A brand new user opens TikTok. 0 followers, 0 history, 0 data. Within 3 video swipes, the app knows them better than Netflix does after 3 years. That is not magic. That is a recommendation pipeline running across 150,000 GPUs, returning 15 ranked videos in under 200 milliseconds. Here's exactly how it works. The average TikTok user spends 95 minutes per day on the app. That beats Netflix, YouTube, and Instagram combined. TikTok processes billions of interaction signals daily. It runs inference at a scale that would bankrupt most startups. Every consumer tech company is trying to replicate this. Most fail. The reason is architectural, and you're about to see why. Every platform before TikTok solved discovery the same way. Show people content from accounts they follow. Simple, logical, completely broken for new users. 0 follows means 0 feed. That is the cold start problem. And it killed early engagement on YouTube and Instagram. TikTok ignored the social graph entirely. That one decision changed everything. Here's the analogy that will make this whole system click. Imagine a busy ER. A nurse quickly scans hundreds of patients and sorts out the obviously fine ones. A doctor narrows to the serious cases. Only then does the expensive specialist run a 2-hour surgery on the final few. TikTok's pipeline works exactly the same way, and we are going to build it layer by layer. Before we go deeper, let us do the math on the naive approach. Take a single deep learning model. It takes 100 milliseconds per video. TikTok has 5 billion videos. Run the model on all of them for one user request. The answer is 5.8 days per request, per user. You cannot score the entire library. You need a cascade. Here's what nobody tells you. When Musical.ly was acquired by ByteDance in 2018, it ran a basic collaborative filtering system. Who else liked what you liked? After ByteDance replaced it with a real-time interest graph that updates after every single interaction, average session time jumped 40% within 6 months. The algorithm did not change the content, it changed the sequencing. That is the whole game. Here's the full cascade. Stage 1, recall, uses fast approximate search to pull 500 candidates from 5 billion in under 10 milliseconds. Stage 2, pre-ranking, drops that to 220 milliseconds. Stage 3, ranking, scores the survivors with a heavy neural model in 100 milliseconds. Stage 4, re-ranking, picks the final 15 and enforces diversity. Total, under 200 milliseconds. The recall stage is the triage nurse. It does not need to be perfect. It needs to be fast and cast wide. TikTok runs multiple recall channels simultaneously. Interest-based, topic-based, trending globally, collaborative filtering, and followed accounts. Each channel fires in parallel. They merge into a pool of 500 to 1,000 candidates. Speed beats precision here. The expensive stages will clean it up. The core ML architecture powering recall is called a 2-tower neural network. 2 completely separate networks. Tower 1 encodes the user, their history, session, location, device. Tower 2 encodes every video, audio, visuals, captions, hashtags. Both towers output a 64-dimensional vector. To match user to video, you just compute the dot product. Closer vectors mean higher relevance. This is why recall is fast. You have a user vector. You have 5 billion video vectors. How do you find the closest ones without comparing all 5 billion? Approximate nearest neighbor search, AN. It builds an index that groups similar vectors together. Instead of scanning everything, it scans clusters. The answer is approximate, not perfect, but it is 99% accurate and returns in under 10 milliseconds. Precision is the doctor's job, not the nurse's. The pre-ranker is the doctor doing a quick assessment. It is a lightweight model, a small 2-layer neural network running on CPU, not GPU. It scores each of the 500 candidates on predicted engagement probability. Takes under 20 milliseconds, drops the bottom 300. The remaining 200 candidates move forward. This stage exists for one reason. Protect the expensive GPU ranker from wasting compute on obvious rejects. This is where the expensive surgery happens. The full deep learning ranker runs on GPU. It takes 200 candidates and predicts 6 engagement signals simultaneously. Completion rate, like probability, share probability, comment probability, replay probability, and follow probability. It also predicts 2 negative signals, not interested clicks and reports. Every signal has a weight. The final score is a weighted sum. This is called multitask learning. At first, predicting 6 signals feels like overkill. Here's why it actually makes sense. A video might get massive likes, but terrible completion rates. People click like on the thumbnail, but bail after 3 seconds. That video is not actually engaging. Completion rate is the most honest signal. By predicting all signals together on a shared model body, the signals reinforce each other. The model learns richer representations than any single signal model could. Here is the infrastructure problem nobody talks about. The ranker needs features about your behavior, like your watch completion rate for cooking videos in the last 5 minutes. That number changes after every single video you watch. The feature store must reflect this in real time. TikTok uses a streaming pipeline. Every interaction fires an event. Flink processes it in a 10-second window, and the result lands in Redis before your next swipe. Not all features need the same freshness. TikTok splits them into 3 categories. Static features, your age, device type, account age, update daily. They live in a distributed database. Medium-term features, your weekly category preferences, update hourly via batch jobs. Real-time features, what you watched in the last 5 minutes, update in under 10 seconds via streaming. Only real-time features live in Redis for sub-50 millisecond reads. A brand new user has no feature vector, no history, no session data. The cold start problem has killed personalization on every platform that ever tried. TikTok's solution is a seed set of 8 to 15 videos, chosen not for maximum engagement, but for maximum information gain. Each video is chosen to reveal something different about the user's taste. After 3 interactions, the system knows which content cluster you belong to. The nurse has triaged you. A perfect recommendation system has a fatal flaw. If it always shows you the content it is most confident you will like, it will show you the same thing forever. You will never discover new interests. New creators will never find an audience. This is the explore versus exploit problem. Always exploiting known preferences creates a filter bubble. You need to intentionally inject uncertainty. TikTok does this with a multi-armed bandit. The multi-armed bandit is a classic problem. You have a row of slot machines. Each has an unknown payout rate. How do you maximize winnings without playing every machine forever? You try unfamiliar machines sometimes, exploration, and play your best-known machine the rest of the time, exploitation. TikTok uses contextual bandits in the re-ranker to inject experimental content, measure its engagement, and update its model. Every user is a live experiment. The re-ranker is where business rules override pure ML scores. 4 constraints apply. Diversity. No 3 videos from the same category in a row. Freshness. Newer content gets a boost over older content with equal scores. Policy. Age restrictions, regional content laws, and advertiser safety filters. Creator diversity. The same creator cannot appear twice in 5 consecutive videos. Only then are the 15 final videos locked and sent to your phone. Let us run through a complete request. You open TikTok. The client sends device metadata and your session token to the recommendation backend. The backend initializes your session context, fires all recall channels in parallel, merges 500 candidates, runs the pre-ranker, runs the GPU ranker, runs re-ranking, and returns 15 videos, all before your thumb has finished swiping. That entire sequence happens in under 200 milliseconds. TikTok's recommendation system runs on ByteDance's internal ML platform, commercialized externally as Byte Plus. The GPU fleet is estimated at 150,000 A100 equivalent GPUs globally, primarily for training and inference. ByteDance built custom models serving infrastructure to hit sub-200 millisecond latency at 1.5 billion users. This is not off-the-shelf tooling. It is purpose-built infrastructure designed for one problem at one scale. TikTok did not invent multi-stage ranking. YouTube published their version in 2016 and refined it in 2019. Same pattern, 2-stage candidate generation then ranking, multitask learning, predicting watch time and likes simultaneously, and deep neural networks for user history encoding. The critical difference, YouTube's system is built around subscriptions and search history. TikTok's is built around pure behavioral signals, no social graph. That is the architectural bet that worked. Remember the hospital triage analogy? Here is how it maps exactly. The recall stage is the fast nurse, imprecise, high throughput, cannot afford to be slow. The pre-ranker is the doctor, smart enough to eliminate the obvious rejects. The full neural ranker is the surgeon, expensive, accurate, reserved for the short list. The re-ranker is hospital policy, ensuring you do not discharge the same patient twice in a row. Every stage earns the right to use the next. In your next system design interview, say exactly this. I would use a multi-stage ranking pipeline. A fast approximate nearest neighbor recall stage pulls candidates from the full corpus in under 10 milliseconds. A lightweight pre-ranker on CPU eliminates low-confidence candidates. A full neural ranker on GPU scores the finalists. A re-ranker enforces diversity in business policy. This pattern is exactly how TikTok and YouTube both solved it at scale. Want to sound like you have built this before? Drop these 3 concepts naturally. First, mention the cold start seed set. The system maximizes information gain for new users, not just engagement. Second, say completion rate is a stronger signal than likes. It cannot be gamed. Third, note that feature freshness is an infrastructure problem as hard as the ML problem. Interviewers at FANG hear these and immediately think senior. Here's how you know the system is working. Feature store read latency should stay under 50 milliseconds at P99. Recall stage should return candidates in under 10 milliseconds. End-to-end feed generation should be under 200 milliseconds. Cold start personalization. The time from first open to a demonstrably personalized feed should happen within 3 to 5 interactions. If any of these degrade, the cascade is the first place you look. This architecture is not unique to TikTok. Netflix uses a cascade to rank 200 million users' homepages. Spotify uses it to generate Discover Weekly. Instagram Reels rebuilt its entire ranking pipeline to match TikTok's approach after seeing the engagement numbers. Amazon uses it to rank product recommendations. Every system that must find 15 relevant items from billions of candidates in under 200 milliseconds is running some version of this 4-stage triage. This breaks everything beginners assume about recommendation systems. The algorithm is not the hard part. The hard part is getting the right signals to the model in under 50 milliseconds at 1.5 billion users. The hard part is designing a cascade that lets a 100 millisecond model run 200 times in under 200 milliseconds total. The hard part is the infrastructure. The ML model is just math on top of an engineering miracle. Here's the entire system in 5 sentences. No social graph, pure behavioral signals. 4-stage cascade, recall, pre-rank, rank, re-rank. 2-tower model, user and video vectors in shared embedding space. Real-time feature store, radius serving signals in under 50 milliseconds. Multi-Armed Bandit, intentional exploration to prevent filter bubbles. That is the TikTok recommendation system. And now you can explain it in an interview. That hospital triage is running right now, 1.5 billion times a day. Fast nurse, doctor, surgeon, policy, in 200 milliseconds. In your next interview, say this: I'd use a multi-stage cascade. Each stage earns the right to use the next. If this clicked, subscribe. The next video breaks down how Spotify builds Discover Weekly.